Hi everyone, my name is Tony Xavier, Chief Learning Officer of IMS and author of the book Bell the Cat, Your Friend, Philosopher and Guide for Cat Prep. In this series of DILR, we are doing a subsection of videos on mathematical reasoning. These are all sets that involve a concept of math, and unless you know that concept, there is no way you can answer the question. And one of the most important concepts that is always tested either in the quant, but not as much as in the quant, as much as in DLR, since eternity, since the time that I've been taking the CAT, is Venn diagrams, and especially the three-factor Venn diagrams. Three-factor Venn diagrams is nothing but Venn diagrams with three circles. Otherwise, you have a two-factor Venn diagram. Right? Now, three-factor Venn diagrams and Venn diagrams questions can be tricky. It is a tricky concept, specifically in the sense that it can become, the questions to solve can get tricky. The concept itself is very simple. There is absolutely nothing to understand. But after that, the questions and the sets that can be made become very, very interesting. This is one thing I've observed, that wherever the concept is very, very straightforward, the questions can get super creative. So, for example, time, speed, distance. Speed into time is equal to distance, right? But you see the most creative questions getting made there. Similarly, probability. Probability is nothing but number of ways in which favorable occurrence can happen divided by total number of occurrences. But problems get super creative. Right? So, whereas if you look at something like logarithms, it can get created, but because there are a fixed number of rules, it is always easier there. It doesn't get super creative over it. Venn diagrams falls into that first category. Very simple on the face of it, but the questions can get tricky. So if you have the concepts in place, then when you see a Venn diagram set, even though it might seem slightly tricky, you can at least answer a couple of questions and step out, right? And if your concepts are really strong, then a moderate or moderate to difficult set, you can look at definitely solving. So in this set, I'm not going to explain the concepts only as concepts. I'm going to explain the concept through the application, right? So through solving the set itself, right? This is again an actual CAT question. And if we look at this actual CAT question, let's see as to how do we look at the concept. Venn diagram falls under the category of set theory, right? Fun Sports provides training in all three sports: Gilli Danda, Kho-Kho and Ludo, that is G, K and L. Currently, it has an enrollment of 39 students, each of whom is enrolled in at least one of the three sports, right? So we know that we will draw three intersecting circles, right? Perfectly intersecting circles, right? Usually in Venn diagrams, you always also draw a rectangle outside. That is to represent how many people are not part of these three, right? So for example, if it says that in a particular class, right, the students are taking Gilli Danda, Kho-Kho and Ludo, right? This thing, right? And 39 people have enrolled. And suppose there is an angle that you don't know what the number of people in the class is, not all people have enrolled, then you draw an outside rectangle. Here they're saying that all 39 students have enrolled in at least one, so you don't need to draw a rectangle outside. Next, they've given all of these conditions. Now, unlike all other sets where I say that, my first commandment is do not rush to draw a table or whatever, with Venn diagrams, the only thing is that you know that you have to represent it in circles. There is no point reading the conditions. You eventually have to go ahead. But there is a point to reading the questions. Why? If you read the questions, you'll know, will all the areas inside the Venn diagram, will you be able to fill them? Or will some areas remain blank? That is dependent on the kind of questions. So let's say the questions. What is the minimum number of students enrolled in both G and L, but not K? Maxima, minima. That means in a particular region, there can be more than one value. That means you won't be able to fill that. So that much you know that in this particular set, not all regions inside the Venn diagram you'll be able to fill. If the number of students are enrolled is 19 to 20, then what is the number, right? So that is one. And for the third and fourth question, they've given more additional information. Due to academic pressure, students who were enrolled in all three sports were asked to withdraw. And for the third and fourth questions, the situation is the same, that people have withdrawn from all three sports. Instead of all three, they're playing only two. They're asked you two questions based on the same thing. After the withdrawal, how many students were enrolled in both G and K? After the withdrawal, how many students were enrolled in both G and L, right? So our task is to use this set to understand three-factor Venn diagrams, right? I don't think there can be sets that are tougher than this. There can be sets that are easier than this. But in terms of testing concepts, if you understand this set properly, you will be able to master what is three-factor Venn diagrams. Now, what are they saying? Three circles, G, L, K, and L, perfectly intersecting. Now, Venn diagrams, the beauty is that what you see is what you get, right? So you know that there is a part which is only G, where people have enrolled only for one sport and not the other. There is a part which is only K, and then there is a part which is only L. Then you know that there is a part which is only G and K. People have only enrolled in G and K. The part which is only G and L, the part which is only L and K, and the part right at the center, all the with intersection of all three is what? Number of people who enrolled for all three. Now you start looking at the conditions. The number of students enrolled only in L is double the number of students enrolled in all three sports. L is double of all three. So if all three is X, then only in L is how much? 2X, right? Only in L is that portion of L which has nothing to do with the other two circles, right? X and 2X. Next condition. There are a total of 17 students enrolled in G. That means the whole of G, that entire circle is 17. The number of students enrolled only in G is 1 less than the number of students only in L. Only in L you have 2X. Only in G is 1 less than that. That means this area is 2X minus 1. Number of students enrolled only in K is equal to the number of students who have enrolled both in K and L. Now, both in K and L, what is that common region both in K and L? Both in K and L is this region where one region is X, right? They did not say only in K and L but not in G. Both in K and L means what is the area common to K and L? It is this whole area. You've already marked this as X. So the other leftover area in that common area between K and L is Y. Now what are they saying? Only in K is equal to the number of students who are enrolled both in K and L. Now whenever I'm saying both set A and set B, it means that whole intersection. When I'm saying only set A and set B but not set C, then it remains a specific part, right? Here it's saying both K and L. So both K and L is X and Y. That is equal to only in K, right? Both K and L is this area and X and Y is this, right? So you should use this set to know what do they say when they mean both K and L, right? Now what's the next one? The maximum student enrollment is in L. 10 students enrolled in G are also enrolled in at least one more sport. 10 students enrolled in G are also enrolled in one more sport. What does that mean? Total number of G is how much? 17. 10 of them are playing more than one sport. That means how many of them are playing only one sport out of 17? If 10 are playing more than one, only one sport is how much? 7. And what is that only one sport? G is equal to 2x minus 1. So you have your equation 2x minus 1 is equal to 7. So x is equal to 4. That much you clearly know. And what do you know? What other piece of information you have? The total amount is, total number of students are how much? 31, right? Now total number of students is equal to, 39, right? Everything, the total is in terms of x and y you can express. You already have the value of x. So if you make an equation of total of x and y and equate it to 39, you can calculate the value of the other unknown in this situation, which is y. Now, when you're calculating the total, you have to add the values of the individual distinct regions, right? Now, whole of G is how much? 17. So take that G part as 17 and then look at all the values outside of G. Outside of G, what are the values? 2x, y, and x plus y. Those are the values outside of G. That is the total which is equal to 39. G is 17. You have 2x is the part, one part is that's outside of G. Y is that other part that is outside of G, and then you have x plus y. So 17 plus 2x plus y plus x, that's 17 plus 3x plus 2y is equal to 39. You just do the maths, you'll get y is equal to 5, right? 3x is nothing but 12, that is 29. So 29 goes that side, 2y is equal to 10, y is equal to 5. Right? So now you have y is equal to 5 means this amount is there. Now you know that all the questions are minima, maxima, what if this, what if that. There is only one condition that you have unused. What is that condition? The maximum number of people are there in L. So that's the Newton condition, that maximum student enrollment is in L. Now, we always said it's the unused condition that will help you unlock the set. You keep this number, you filled this, the questions are now asking min-max. Now go to the question. What is the minimum number of students enrolled in G and L but not in K? G and L but not in K, which area this is? It is this area, right? Now, so that is the unknown area, you keep that as X. G and L but not in K, right? So if this is X, this is 7 and this is 4. So total of G is how much? 17. These three areas, there are 4 areas. These 3 areas are what? 11 plus X. So what is the remaining area? 17 minus 11 plus X, that is 6 minus X. So this remaining portion is 6 minus X. Now this whole thing is full. The maximum amount is in L. Now you go ahead and see what can be done, right? L is equal to how much total? 17 plus X. L total is 8 plus 4 plus 5, that is 12 plus 5, 17 plus X. G total we know is 17. K total is how much? Add all of these parts. 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 9 is 24, 24 minus X. Now what do you know? Maximum student enrollment is in L. That means L is greater than K. That means 17 is greater than 24 minus X. 17 is greater than 24 minus X means 2X is greater than 7, X is greater than 3.5. Can X be a decimal? No, because X is number of people. So X has to be a number. So the least number greater than 3.5 is how much? 4. So what is the minimum number that is here enrolled in what you call G and L but not in K? That is equal to 4. Here straight away you can mark the answer, but because you know the minimum and there are some limits, you should calculate the maximum as well. X can be 4. What is the maximum that X can be? This area? It has to be 6. Why? Because this area 6 minus X, right? So if X is equal to 6, in that area there will be 0 people. But if X is more than 6, that will become negative. Can there be negative number of people? No. So the maximum value of X in this particular area, which is intersection of G and K, but not L, that can be 0 but not negative. So X can be a maximum of 6. So you have this. In this particular question, minimum number of students enrolled both in G and L but not in K, that is the value of X. The answer is 4. Now we go to the next question. If the number of students enrolled in K and L, total K circle plus total K circle plus total L circle is in the ratio 19:22, how many students are enrolled in L, right? We already know that L is 17 plus X, G is 17, K is 24 minus X, okay? And they're saying the ratio is 19:22, right? Now you have to see that this is already something which has been, this is a fraction. Now whenever they give you a ratio, suppose I give you a ratio 6:8. You know that can be reduced further. You can go that 2 goes 3 times and 2 goes 4 times. The ratio is 3:4, right? So beyond 3:4, this ratio cannot be reduced, right? So if I say class A and class B are in the ratio 3:4, what does that mean, the number of students? They're either 3 students or 4 students, or the next set are multiples. They can be 6 or 8. They can be into 3, which is how much? 9 or 12. They can be 12 or 16. So it is all multiples of 3 and multiples of 4, numerator and denominator. These are the possible values of class A and class B, right? Because the base value, the lowest possible value is 3:4. Here 19:22. Can this fraction be reduced further? No, because 19 is a prime number. You cannot cancel anything. That means K/L is what? First bare minimum value is 19:22. Next value is what? 38:44. Next multiple, 19 into 2, 22 into 2, right? So K and L can be 19 or 22 or 38 and 44. So you might ask, sir, but how can it be 38 and 44? Because total number of people are only 39. Total number of people are 39, but there is an intersection, right? There is an intersection where there is an intersection between K and L, there is an intersection, right? So that when I'm taking the ratio, when I'm taking K separately and L separately, right, there is an overlap, so they will be double counting, which is why individually K and L, the number can be 38 or 44. Right? Now, we have to see what is the possible value. Is it 1922? Is it 3844 or higher? Now, if L is equal to 22, K is to L is 19 and 22. If L equal to 22, what is the value of L? 17 plus X. If L is equal to 22, X is equal to how much? 5, right? X will be equal to 5 and K will be equal to how much? 24 minus X, it will be 19. If L is equal to the next value, 44, then what happens? L is 17 plus X. 17 plus X is equal to 44. That means X is how much? 27, right? Now, if X is 27, K will be 24 minus X. 24 minus 27 is minus 3. Can it be negative? No. So, that means L has to be equal to 22. If the number of students enrolled in K and L is in the ratio 19 is to 22, how many students are enrolled in L? 22, right? Now, these two are actually the easy questions here. And even if you have like a basic understanding of how Venn diagrams work, we know of three-factor Venn diagrams work. 3 circles, you know what it's meant by only X, only Y, both this one, both this but not this. If you know that, you can solve this, and in around the 6 minutes time, you can get those 6 marks and step out, right? This is the doable version where if you want to crack the CAT, this level you should be able to do. Now the next 2 questions, so because this is easy or easy moderate. The next 2 questions go into the moderate to difficult. They're not moderate. They're between moderate and difficult. And if you can solve this, that is what which will take you to the 99. So the best thing in some of the sets is that you can know the exact level, which is a 99 level, and the level which is a 95. If you're able to solve the first 2 ones comfortably, you'll get a 95 percentile on the DLR. That's the level in terms of capability. If you're able to solve this, then definitely the next level. You don't need to solve the difficult one. The difficult one can be left, absolutely, but you'll still get a 99 percentile. Now, please focus here. We know the 3 numbers and everything. Understanding this concept is very, very important. What are they saying? Due to academic pressure, students who enrolled in all 3 sports were asked to withdraw from at least one sport, right? There are some people who are playing all 3. Right? They're asked to withdraw from one sport, right? That means instead of playing all 3, how many do they end up playing? 2. That means instead of being in the innermost area, they're going to go that person who's now, suppose you have to put that person there, right? You have to take a photo and put that person there. That person right now will be in that innermost area, which is 4. Now, because that person is saying you have to give up one sport, that person has to go out of the innermost area. If they're going out of the innermost area, they will be going into the area of one of the playing 2 sports. Because I'm playing 3, I'm giving up 1. Right? So now if you look at this, suppose I look at somebody in the L circle. L circle part of all 3. Now somebody in L circle part of all 3, if they're giving up one sport, right? Where will they end up going? From that common thing. So one person, from that L is actually giving up L. So G, K and L, I'm part of L and I'm, there in that all 3 part. I'm giving up L. If I'm giving up L, where will I go? I'm sorry. If I'm giving up L, where will I go? I'll just go outside that circle L. Outside that circle L, where will I go? I'll go to that common area of G and K. Right? Similarly, I'm playing all 3 and I give up K. If I give up K, where will I go? I'll exactly go to this part, right? Which is outside of K, but common. And I give up G, where will I go? Exactly outside of G here, right? Now, this is something that you need to understand. So I'm going outside, right? The total number of people is still 39, but the people in each area is decreasing. Now, here they're saying 4 people are going out and at least one person is leaving each sport. So one person is leaving Gilli Danda, one person is leaving Kho-Kho, one person is leaving Ludo. Total 4 people are leaving. At least one person each. That means 3, 1, 1, 1 is in G, K and L. 4 people means that one person, extra person, is from one of the 3. So the number of people leaving G, K and L, there are 2 1s and 1 2. Now what else are they doing? After the withdrawal, number of students enrolled in G was 6 less than the total number of students of L. L total minus G total is equal to 6, while the number of students enrolled in K went down by 1. That means one person left K. So out of 4 people who left, 1 person left K. The remaining 3 people were left G and remaining 3 people left G and L. That means it can be 2 people left G, 1 person left L, or 1 person left L and 2 people left L and 1 person left G. Because minimum 1 person has left every sport, so it cannot be 3-0, right? So G, K and L, G is 2, K is 1, L is 1, or G is 1, K is 1, L is 2. That's the total of 4, right? So you have that here, K is equal to 1 and G and L are here. Now let us say, let's suppose that the people withdrawing G, K and L, right, the number be small g, small k and small l. So the person leaving L will just go to that part outside of L. So that common portion of G and K, which is 6 minus x, that person leaving L will come there. So that becomes 6 minus x plus L. Similarly, the person leaving K will come to this part, which is which is the common portion between outside of K. So that portion becomes x plus K. Similarly, the person leaving G will come to the common portion here, which will become. Now, what's the condition that you know? L minus G is equal to 6. L minus G is equal to 6. What's the total of L? If I look at the total of L, it is what? 8 plus 4 is 8 plus 4 is 12, 12 plus 5 is 17, and the rest of the variables are x plus G. Similarly, total of G is what? 7 plus, total is, 7 plus 4 plus 6, that is 17, minus x and plus x get cancelled, you have k plus L. Now, L minus G, if you do that subtraction, x plus G minus L is equal to 6. X plus G minus L is equal to 6. G is either G and L are what? 2, 1 or 1, 2. G minus L will be, if it is 2, 1, G minus L will be 1. If it is 1, 2, G minus L will be minus 1. So you know that G minus L is either plus 1 or minus 1. That means x is this equation, x plus G minus L is equal to 6. It's either x minus 1 is equal to 6 or x plus 1 is equal to 6. One of the two is true. X minus 1 is equal to 6 or x plus 1 is equal to 6. Now, right at the beginning, we figured something about x. What was that in the set? The minimum value of x is 4. Maximum value of x is 6. That means x can be 4, 5 or 6. Now you know that it also has to satisfy this equation, that either it is x minus 1 is equal to 6 or x plus 1 is equal to 6. So take this value of 4, 5 and 6 and see in which case it is satisfying. If I take x is equal to 4, will x minus 1 be equal to 6? 4 minus 1 not equal to 6. X plus 1, will it be equal to 6? 4 plus 1? No. So 4 is not possible. If I take x minus, x is equal to 6. X is equal to 6 means x minus 1 is how much? 6 minus 1 is equal to 6? No, it's equal to 5. X is equal to 6 means x plus 1 is equal to 6, 6 plus 1 is equal to 7. So 4 and 6 are not possible, only 5 is possible. In the case of 5, x plus 1 is equal to 6, 5 plus 1 will be equal to 6. So we know that x is equal to 5 is possible. That means G is, have the value of x plus 1, and you know that G is equal to 2 and L is equal to 1. So what are they asking you in this question? After the withdrawal, how many students were enrolled both in G and K? Both in G and K, the value is how much? 6 minus x plus L. X is equal to 5. So that is 6 minus 5 plus L is equal to 1 plus 1. 6 minus 5 plus 1 is what? G plus K is equal to 2. So that's the answer on this one. The next question based on the same thing. After the withdrawal, how many students were both enrolled in both G and L, right? Both G and L, the number is how much? X plus K, and X is equal to 5, K is equal to 1. That means X plus K is equal to 6. After the withdrawal, there is only. Now you must ask, sir, both G and L, you are taking only this X plus K value. You said earlier that G and L together means that whole thing, including the intersection. But after the withdrawal, what has happened? That 4 part has become empty, it has actually become 0. So that change has to be made. So that 4 is 0. Everything in the 4 has now moved into G and L and X. So X is equal to 5, K is equal to 1. So X plus 1 is equal to 6. Right. So that's the 3-factor Venn diagram video. Now, if you take your time, this is not an easy set to understand, especially the last 2 parts. Even if you take a long time to understand, sit, Do it yourself, follow the video. But once you understand this, uh, trust me that your understanding of three-factor Venn diagram becomes very strong, because it's only at this level. And then whenever you see a three-factor Venn diagram, you won't be scared of answering, right? I hope this video was useful. Thank you.